Let's talk about problem 78 on page N. It's similar to several other problems on this page, as well as what you'll see on the checkup and self-test. But it is a think problem, and that's because there's one extra step at the end. And so I think when we explain it and kind of go over that, it'll make sense. The problem says if a current of 20 amps passes through 500 grams of mercury for a period of 2 hours, what will be the amount of mercury remaining? Now, normally we are solving for M. M is the mass that is being liberated. And the formula for that is the mass liberated is Z times I, which is current, times T, which is time. Now the current is given, 20 amps. Yay, that's easy. Okay. The time has to be in seconds, so they give it to us in hours. So we're going to take 2 hours times 60 minutes times 60 seconds. Okay, I'm going to let you do that on your own. And then you're going to take that number and plug it in down here for the time. We can take the 20, plug it in here for I, okay? And then the Z value is real easy to find. We look up this on the chart. So the equivalent mass is called for mercury is 100.3. And that was on a table in the PACE. The Faraday is a constant, yay! So that's just a number that we use. We don't have to calculate this. We don't have to look it up. Faraday is always the same number. So now when you divide this divided by this, we get this long decimal number. We're going to keep it long like that and plug it in over here for Z. So we have Z, we have I, and then once you have the time, multiply them together. But that's not our final answer. That will be this number, the amount of mass liberated. And the question is, how much of the 500 grams of mercury will be remaining? Okay, so we'll take the 500 and subtract the mass that was liberated, and that will be your answer. So again, I'm not going to do the math for you. You can follow those steps and solve that. I believe this problem is also found in the solution guide at the back of the Squirky.